Hello everyone, welcome to Chemizon Complete Chemistry. So in today's video we are going to see this question 39 of the GATE 2022 chemistry paper, which is based on dipole-dipolarophile reaction. What is this reaction? It is a type of cycloaddition reaction, which is a type of pericyclic reaction. So this is the question. We have to identify the product P. Okay, so first, we will see what exactly is dipole-dipolarophile reaction, and then we will also see its stereochemistry. So let us first understand this reaction, dipole-dipolarophile reaction, is similar to that of diene-dienophile reaction. That is nothing but Diels-Alder reaction. Diene-dienophile or Diels-Alder reaction. So what exactly happens in a Diels-Alder reaction? There is an electron-rich diene. That is, what is di? Di means two, ene means double bond. So there is a compound having two double bond. This is called diene. Okay, 1, 2, 3, 4. So this is 1,3-butadiene. 1,3-buta means 4 carbon, di means 2 and ene means double bond. So 4 carbon having two double bonds at 1 and 3rd position, plus it is reacting with another compound having one double bond, that is called as dienophile. Okay, how this reaction takes place? This will attack here, this pi electrons will attack here, and here there is formation of a new pi bond. So what is the product? Product is a 6-membered ring, like this. So what is the difference between this diene-dienophile and dipole-dipolarophile reaction? Okay, the only difference is dipolarophile is the same. Okay, dipolarophile is what? It is a dipolarophile is a compound having single bond, single double bond. Okay, let's say alkene, ethene. Okay, compound having one double bond. Compound is same, only the name is changed. It here name was dienophile, here it is dipolarophile. What is different is the dipole. Okay, it is called 1,3 dipole. Why? In diene, if you see 2 plus 2, 4 pi electrons. Okay, 4 pi electrons are shared over 1, 2, 3 and 4. 4 pi electrons are shared over 4 atoms. Whereas in dipole, 1,3 dipole, if you see, okay, let us see what is 1,3 dipole. So here, if you see, what will happen is 4 pi electrons are shared over 3 atoms. Okay, so in this diagram here you can see one is the two lone pair of the 2 electron or one lone pair of atom A. This is 2 pi electrons plus 2 pi electrons from this pi bond. 4 pi electrons are shared over only 3 atoms, 1, 2 and 3. Okay, so that is why it is called 1, 2, 3. 1, 2, 1, 2, 1, 3. It is called as 1,3 dipole. Okay, it is called as 1,3 dipole because there are 3 atoms that are sharing the 4 pi electrons. Okay, so what exactly happens here is the mechanism is similar to Diels-Alder reaction. One pi compound having single double bond that reacts, that is called as dipolarophile, and this is the cyclic transition state. Okay, and there is this, why this is called dipole? Di means two, pole, there is presence of two poles, or we can say there is presence of charge separation. Okay, charge separation, just like any polar bond, here there is charge separation. That is why we call it as dipole. Okay, cyclic transition state, and in the product you can see the atom which had positive charge will now get its lone pair back, so it does not have any charge. Okay, so this is a general reaction. Now the most important part of this question is to understand the stereochemistry. So this reaction is what it is called as stereospecific. Okay, this we had seen already. Stereo means it can be either enantiomers or diastereomers. Here you can see cis trans is mentioned. That means they are geometrical isomers. Uh, that is diastereomers. So what will happen here is uh, stereospecific. Specific means only one particular isomer will be formed. Okay, so if the alkene is cis, Okay, that is of the dipolarophile. We are talking about the stereochemistry of the dipolarophile. Okay, that is a compound having one double bond. If the dipolarophile has cis stereochemistry, then the product also has cis stereochemistry. And if the double bond is trans, alkene is trans, then the product is also trans. Now, why this is called cis and trans? We know both the groups are above the plane having same stereochemistry. That is why they are cis. One group is above the plane, another group is below the plane. So here it is trans. Okay, so now let us see the actual question that is given. So methyl, I'm writing CH3, then there is single bond, then carbon, then triple bond, nitrogen having positive charge, oxygen having 3 lone pairs. That is why it is having a negative charge. And it is reacting it with dipolarophile, that is alkene. So this is which alkene, cis or trans? So you can see here that higher priority group, that is same groups are present on the same side of the double bond. So this is what cis alkene. So the product formed will also be cis. Okay, so how this reaction take place? This negative charge will attack here. This pi electrons will attack the carbon and nitrogen will get its lone pair. Triple bond will become double bond. So what do we get is, the product that we get here is carbon, double bond nitrogen. The central atom, it had positive charge. Now it has got its lone pair back, just like we saw in the general reaction here. Okay, you can see the central atom got its lone pair back. And here we have methyl, oxygen, carbon, carbon. Now let's say I will write both the methyl groups above the plane of the paper, that is cis stereochemistry. CH3, below the plane there is hydrogen. Here also below the plane there is hydrogen. Now what is happening? The next step is we do reduction. A catalytic reduction using hydrogen and Raney nickel. So what will happen? A polar bond will break. Okay, this is called as hydrogenolysis. Okay, lysis means breaking of a particular bond as well as addition of hydrogenation. Okay, hydrogenation means addition of hydrogen plus there will be some bond that is breaking. Which bond will be breaking? This polar NO bond will be breaking like this. Okay, here hydrogen will be added, here also hydrogen will be added. Okay, so what we will get is C double bond NH. Here we have methyl. Then here carbon, below the plane there is hydrogen, above the plane there is methyl, and this carbon, below the plane again there is hydrogen, and above the plane there is methyl. And here in plane we have OH. Okay, in plane we have OH. So but in the options, if you see, okay, in all the options if you see, the methyl is present in plane. Okay, methyl is present in plane. So what we have to do is we have to rotate this molecule such that the methyl comes in plane. Okay, so there are two methods. Either we can do it directly, that is I bring this methyl here. Okay, it is above the plane, now it will come in plane. Now hydrogen, if I rotate, okay, I will rotate it by 60 degrees like this. So hydrogen will come on the left. Left means below the plane, and this OH which was above, which was in plane, will now come on the right. Right means above the plane on the wedge bond. Okay, or you can do like this. OH on the left, that there is hydrogen, CH3. Okay, what we can do, we can rotate like this. This will come here and this OH will come here. So what we get is CH3 in plane, OH above the plane, and hydrogen below the plane. Okay, so we can change the stereochemistry now. Hydrogen, which was below the plane, it has, okay, hydrogen has now come, it will remain below the plane, and OH will come on the right. That means it will come above the plane like this. OH is above the plane and methyl will now come in plane. Okay, methyl will come in plane of the paper. Okay, so this was hydrogenolysis that is completed. Now what we have to do is we have to do the last step is hydrolysis of this imine group, that is addition of water. Now imines, carbon and nitrogen, which is more electronegative? Nitrogen. Carbon is less electronegative. If you see water molecule, this is more electronegative, this is hydrogen is less electronegative. So nitrogen is more electronegative, so it will pick up H plus ion, and carbon we will add OH. So what exactly happens is, first pi bond is breaking. Okay, nitrogen we will add hydrogen here, and at the carbon we will add OH. Okay, one pi bond is broken. Again the process will be repeated. Another pi bond will also break, and here we will add one more hydrogen, and here we will add OH. So now what has happened is, okay, this OH I can write here. Okay, so now what has happened is this, you can see this is which molecule? Ammonia molecule is released, and here at one carbon, two OH groups are not stable, so there will be loss of water molecule. H plus will be released from here and OH minus from here. So what exactly will happen is we will get carbon oxygen double bond, that is ketone will be formed. Okay, so basically what we did here is C double bond NH, we broke this imine bond, we did hydrolysis of this imine, and what we got is ketone plus ammonia. Okay, so this is the final product. So if you see the stereochemistry of this group, you can see methyl and OH both are cis. Okay, that is above the plane, so that will be the correct answer. So methyl and OH, they are cis to each other in option 1, option A. Here they are trans, so this is incorrect. Here there is no stereochemistry, incorrect. Option D, okay, they are trans, that is incorrect, and ketone group is also missing. So the only correct answer is option A. I hope you have understood the solution. Thank you.